Comparing short run and long run labor demand curves. In both the short run and the long run, the labor demand curve is the marginal revenue product curve of labor. In the short run, the firm cannot vary capital, so the short run marginal product of labor curve and hence the short run marginal revenue product of labor curve are relatively steep. In the long run, when the firm can vary all inputs, its long run marginal product of labor curve and marginal revenue product of labor curve are flatter. Figure 15.2 illustrates this difference for the Canadian thread mill, where P equals $50 per unit and R is $5 per hour. On the short run labor demand curve, where capital is fixed at capital K bar equals 32, the firm hires 32 workers per hour at wage W equals $15. Using 32 workers and 32 units of capital is profit maximizing in the long run. So point A is also on the firm's long run demand curve. The short run labor demand curve is steeper than the long run curve at point A. Superscript 4, which reads, if P equals $50, the Canadian thread mill's short run labor demand equation is capital L. Labor is approximately equal to 27,885.48 W to the power of negative 2.5. In contrast, if R equals $5, its long run labor demand equation is capital L equals 1,620,000 W to the power of negative 4. At W equals $15, the two curves intersect at capital L equals 32, as figure 15.2 shows. At that point, the change in labor with respect to a change in the wage on the short run labor demand curve is the derivative of labor with respect to wage is approximately negative 25 multiplied by open parentheses 27,885.48 close parentheses multiplied by W to the power negative 1.5 is approximately equal to negative 1,200, and the corresponding derivative along the long run curve is the derivative of labor with respect to wage equals negative 4 multiplied by open parentheses 1,620,000 close parentheses times W to the power of negative 3 equals negative 1,920. Thus, the slope of the short run labor demand curve, the derivative of wage with respect to labor, is steeper than that of the long run curve. Figure 15.2, labor demand curves of a thread mill. Describing the picture, on the vertical axis we have wage, which is the marginal revenue product of labor in terms of dollar per hour. And on the horizontal axis, we have capital L for workers per hour. Now there's a few, there's a short run labor demand, or capital K bar is equal to 108. And that intersects the long run labor demand curve at wage is equal to 10 and workers equals to 162 at point C. And the long run labor demand also intersects the short run labor demand, where wage is equal to, where capital K bar is equal to 32. And at this short run labor demand intersecting the long run labor demand at point A, where 15 is the wage and 32 is workers per hour. There's also point B on the short run labor demand, where capital K bar equals 32, where wage is equal to 10 and workers per hour is equal to 88. Now the text reads, if the long run market price of $50 per unit, the rental rate of capital services is R equals $5, and the wage is W equals $15 per hour. A Canadian thread mill hires 32 workers and uses 32 units of capital at point A on its long run labor demand curve. In the short run, if capital is fixed at capital K bar equals 32, the firm still hires 32 workers per hour at point A on its short run labor demand curve. If the wage drops to $10 and capital remains fixed at capital K bar equals 32, the firm would hire 88 workers. Point B on the short run labor demand curve. In the long run, however, it would increase its capital to capital K equals 108 and hire 162 workers. Point C on the long run labor demand curve, and on the short run labor demand curve with capital K bar equals 108.